Okay, ladies and gentlemen, let's take a look at surface area of a pyramid. Now, surface area of a pyramid, there we go. Uh-oh, I lost a chunk of pyramid. Oh well. Okay, so surface area of a pyramid. In this case, we have something that looks like this. Now, unlike your prisms where you have rectangle, 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 base, base, or rectangle, 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 rectangle all the way around, funky base, or you now have something in this ballpark where you have triangle for a base and then triangle for a side, triangle for a side, triangle for a side. Or in this case, you have a square for a base, but you have triangle for a side, triangle for a side, triangle for a side, triangle for a side. So this obviously is going to be a slightly different formula than the formula for a prism. So surface area, not volume, surface area of a prism is 2b plus pH. Well, that's nice, 2b plus pH. The problem is for surface area of a pyramid, I don't need 2b plus pH because my b, I only need one of them dudes because there's only one base. This base is literally non-existent. It's just a point here. So I only need one base, so let's fix that right away. Now, as far as perimeter times height, that might still work out with some of that stuff, but let's take a look if we wrap our pyramid in a surface. So here we go, wrap pyramid in the surface. Because of the space in the wood, it didn't make a perfect pyramid, but you get the idea here. You take this and you unfold it, and you have one triangle this way, one triangle this way, one triangle this way, one triangle this way, and a base. So if I turn it over, I get a very nice one of these fellas. And I get a base. Got it. Check. And I need 1, 2, 3, 4 triangles. So if I have base plus 4 triangles, that's going to be 1/2, let's say length, because that would be the length, right? Now, if I happen to have a square, it would be length, 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 length. Okay. 4 lengths times a height. Now, unfortunately, the height of the figure that goes straight from here and meets this point down here at the center between my two fingers, that height is going to be different than a height that's drawn up the side of the figure. So let's see if we can draw one right down the middle of the figure here. There we go. So this height drawn down the side is going to be a lot longer than just the distance between my fingers. In fact, if you look, if I made a height right here, this height is actually the leg of a triangle that connects to the halfway point. So I have this leg of a triangle, this leg of a triangle, and this leg of a triangle. In fact, we'll need that a little bit later. So I would have the height, but it can't be the height of the figure, so I can't use pH. I'm going to have to use this side right up here. It's the length down the side. It's called L. Now, we usually use a cursive L for lateral height, okay? Lateral height, so it's the height up the side. So I have all these little lateral heights here, and they all meet up at the center and make a nice pyramid here. So I have lateral height. So P length times little l, okay? Now, what if it's not? What if the pyramid is not a square, and now I have lengths and widths? Well, what I really end up with is a length, and if it's not square, a width and a length and a width. But wait a minute, length times width, so I have a base plus a 1/2 length L plus 1/2 width L plus 1/2 length L plus 1/2 width L. Okay, but I can take all the halves out. I can take all the little L's out, and then I'd be left with length plus width plus length plus width. And wait a minute, we've run into this before. Length, width is nothing but perimeter. So I get to keep my perimeter. So in the end, my formula for surface area of a pyramid is one base, whatever that base happens to be. It could be length times width, could be 1/4 square root of 3 sides squared if it's an equilateral triangle, doesn't matter. Okay, and you have length, so you have base plus 1/2 PL, lowercase l or recursive L, 1/2 PL. So in our case, here's what I have. I have a square pyramid with a height down the middle and a length down the edge. See, there's that length. See, side of a triangle, side of a triangle, side of a triangle I was talking about. And if this is 3.5 wide by 3.5 wide, and it is 1 3/4 tall, by the way, I could take 1 3/4 here and 1 3/4 here, use Pythagorean theorem, and I'm going to come up with something around 2.5 for the slant height down that side. Put in all the rest of my heights here. Here we go. And now I can say surface area equals base plus 1/2 PL. Surface area is going to equal base, which is 3.5 times 3.5, plus 1/2 perimeter. Well, 3.5 plus 3.5 plus 3.5 plus 3.5, that's 7, that's 14, times L, 2.5. The surface area here is going to be 3.5 times 3.5. That's 12.25 plus 0.5 times 14 times 2.5. And I get plus 17.5. Put it all together, and I get 29.75. I would have to have 29.75 inches of paper to figure that out. Hey, by the way, you want to do something fun? Let's do something fun. What you could do is think about it in terms of this. Cut off all of your triangles. And in fact, I think I should only need to do one of these. There we go. And I would have one base plus, now, if I take these and reorganize them into this, take 1/2, put it here, 1/2, put it here, there it is. In this case, I would have the length up the side, L, which we already talked about, and half of a perimeter. How do I know it's half of a perimeter? Well, that's only two sides. At only two sides long, I have one length and another length. It's only half the perimeter. So I have base plus 1/2 the perimeter times the height of this rectangle here is L. And there I go. I could find the same exact thing. So that is finding surface area of a pyramid. By the way, surface area of a cone. If I have a cone, it's going to work the same way, and we'll talk about that in a future piece.